Number 7 says graph the system of inequalities below on graph paper. So I copied and pasted a little blank graph that I got from Google. Let's graph this inequality first because I think we're more comfortable with graphing linear inequalities versus quadratic ones. Remember that when you're graphing an inequality on a graph like this, less than or equal to and greater than or equal to give you a solid line or a solid parabola. But when we have less than or greater than, instead of that line or curve being solid, it's going to either be dotted or dashed. Okay, either one, just to show that that line or curve is not part of the solution. So if we graph this linear inequality first, let's start with our y-intercept. My y-intercept is 2, is at 2, so I'm going to draw a point there first. How do I know this? Well, because these are in mx plus b form, and we know that b is our y-intercept and m is our slope. Okay, so my slope then, well, there's no number in front of x, but 1x is equal to x, so my slope would be 1, which means that if you draw your slope triangle, I'm just going to be going up 1 and over 1, and up 1 and over 1. And so connecting these points would give me a line like this. Solid line like we said, and now I'm going to test a point to see where to shade it. So let's test 0, 0, since we know that that's a pretty easy point to test. I'm going to copy down that inequality, plug in 0 for x and 0 for y. Let's see. Is 0 greater than or equal to 2? It is not. So 0, 0 is not a solution. So we're going to shade away. Not shade towards 0, 0, shade away. So that means instead of shading down below, we are going to shade up above. So like this. Now let's graph this quadratic inequality. Because we have the less than symbol, I know that this is going to be a dashed parabola. And how do I know that it's going to be a parabola? Because of that x squared. Okay. How do you begin to graph a parabola? We can always make a table. So make an XY table, get some negative and positive values of x in there, and to get my y values, to draw that boundary graph, just plug in x into the x squared. So for example, to figure out what y is when you plug in -3 for x, you're going to just do this. Plug in -3. What is -3 squared? That's +9. Okay. Now let's plug in -2. What's -2 squared? +4. Okay, so you're basically just squaring all of these x values. -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So plot all of these points on your graph. Let's see, -3, 9 is here. -2, 4 is here. -1, 1 is here. 0, 0. 1, 1, 2, 4, 3, 9. And we're going to draw a dotted or dashed if you want curve. Okay. And now we're going to figure out what side to shade by testing a point. I want you to notice that 0, 0 falls on this parabola. It's a point that is part of that parabola, so I don't want to test it. I never want to test a point that falls on the line or falls on the parabola. So let's test a different point. Let's test, let's see. Let's test a point inside the parabola. Let's do 0, 5. So we're testing 0, 5, and again, not 0, 0, because it falls on the parabola. So take your original inequality, plug in, let's see, 0 for x and 5 for y. So 5 here and 0 here. Let's see, 5 is less than 0 squared is 0. Is 5 less than 0? It's not. So 0, 5 is not a solution. So that means we're going to shade away from 0, 5. Instead of shading on the inside of the parabola, we will be shading on the outside. So out here. Everything on the outside. Where's my solution region then? It's where I have overlap, so that would be all of this. Solution region. Okay. And that is it.